I have figured out a way of implementing traits in JavaScript, and there's a lot of different ways of doing something trait-like in JavaScript, but this way makes a lot of sense to me, and I'm going to share it with you. If you don't know what traits are, effectively when you're doing object-oriented inheritance, for the most part what that means is that you have a class that's going to act as a parent class and another class that's going to act as a child class, and the child is going to inherit from the parent, meaning it pulls in properties and functions and things like that from the parent, and then the child can overwrite those to customize behavior. If you want the child to be able to inherit functions from different classes, you might have multiple inheritance where it has more than one parent, and you can start getting kind of messy. Traits effectively says instead of dealing in terms of what things are, I'm a dog that inherits from mammal, I'm going to deal in terms of what things are. I'm a thing that can jump, so I'm going to implement the jump trait, which contains all of the functions I might need for doing the jumping. And then I can take that trait and stick it on dogs and cats and grasshoppers and anything else without having to figure out exactly what I am and where I fit into this taxonomy of identity. So we're going to do that in JavaScript. Since JavaScript has classes built in, we are going to use classes, but we're going to take advantage of the sort of prototype under the hood system in JavaScript to implement traits. I'm going to go ahead and make my initial JavaScript file here. And so I was trying to use Vim in VS Code to start learning Vim. I'm going to disable it for now because I'm not very good yet. But basically what we're going to do, and I'm going to split this up into a couple different files. I'm going to do a trait.mjs file to implement our initial functions, is I'm going to set us up with an assert function. This is not specifically related to the traits yet, but this is going to be useful for me to do to use the traits the way that I want to use them. And effectively what I'm going to do with this is just say if an expression is not true, then throw an error with a given message. All right, that's all that's going to do. It'll just make it easy for me to be able to add checks and stuff like that. But we're going to do two functions. We're going to do withTraits, where we pass in traits and we pass in a class. And we're going to end up returning a class out of that that has the traits on it. And we're going to do a hasTrait function where we can pass in an object and a trait and get out a Boolean of whether or not that that object implements that trait. So these are going to be our two functions, and in here, in here we're going to use those. We're going to get, well, we might as well get assert. We're going to get withTraits, and we're going to get hasTrait trait from that. And effectively what we would do is we would build a class. And what I'm going to do is show you kind of like how I would use it, and then we'll go and implement it, and I'll show you how to implement it. What I like to be able to do is say we have a person class or something like that, and that's going to be with trait. Well, let's go ahead and do the class first. Let's do a class person. And this is going to have some properties. Let's do some private properties, name and age. And we'll construct those with name and age. This dot name equals name, age equals age. Wonderful. We're going to do getters and setters for those. So if you don't already know the reason you would do private properties like this in a class is I can control exactly what happens when those get set, which means I can do things like make sure that only the things that are allowed to get set get set. So when you get name, we're just going to return this dot name. We're going to turn that private property. And when we set name with a value, v for value, we can make sure that before we do this dot name equals value, that we actually assert that the type of v is a string. String, nope, string. And that would be something like the name property of person must be a string. All right, so now if anybody tries to, we're going to do Bob equals a new person, and his name is Bob, and maybe his age is 18. If instead of doing that, we tried to pass in, undefined, then that would throw. You would not be able to have a person with that. You also couldn't throw in a number or anything like that. This will break it. So And it's nice because instead of throwing that assert into the constructor for just building it, if later we want to do bob.name equals 5, if this assert was in the constructor, then that wouldn't catch. But since we're doing it in the setter, and we're using the setter by doing this.name instead of this.hashname like that, we're going to be able to catch it whenever we do that, which means whenever we use bob.name, we have a reasonable expectation that that's going to be a string. I realize this has nothing to do with traits yet, so hang with me. So we've got that. Let's do the same thing for age. Let's get age. And let's do a setter on age. We'll assert that the type of the value being given is a number. And if it's not, it'll throw the age property. Must be a number. All right. And then after that, we set age to that value. Lovely. Let's confirm that all that works before we move on. We've got a person in here. Let's do Bob's name and Bob's age. Bob, 18. All right. That's looking pretty good. Now, we've got this class in here, and we want any class to be able to do, voting. Or, you got to be 18 years old, and you want to call a vote method, and you want to have something happen. But you want this vote method that the class can do. You want to be able to get that and use that on any other classes. You might have other classes that want to do this sort of thing. So we're going to break it out into its own thing. It'll be a trait. We'll call it can vote and just set it to a plain object, and we'll define vote on there. Now, one thing we can do is just log I am voting, but maybe you want to say this.name is voting and assume that you have a name. Now, the thing is, if you take this then and you put that on a class that doesn't have a name property, then that's not going to work. So you can add additional checks and stuff, assert in here somewhere. But for now, we're just going to do I am voting to make it simple. And maybe we do, you know what? Actually, let's do that. Let's do name is voting, and let's do may vote and return this dot age is greater than equal to 18. So you've got to be 18. And then also let's do if this may vote, then we're going to do that. And otherwise, may not vote. May not vote. May not vote. All right. We got a few functions here. We got some functionality, and this should apply to anybody as long as they can do the can vote. So what we're going to want to be able to do here is tack these onto here. And unfortunately, we can't just do a nice little ... can vote in here, which would be the case if this was just an object. So what I would like to be able to do is say something like this. Cost person is going to be, and we're going to do withTraits and pass in that can vote trait, and then have a class and close that into the function call like that. So this will return the class, but with the traits added into it, right? So what we need, let me check something. Yeah. So what we need to do is implement this method so that we can actually get the class out that we want. So that down here, we can do bob.vote. So let's do that. In withTraits, here's not the magic, but here's the implementation. We're going to loop through traits, and we got to return. So we're going to return. No, we're not. We're going to loop through traits, dot for each, right? What we're going to end up returning actually is we're going to return the class. Am I mixing up throwing semicolons on things? No, I think I've done pretty well leaving them off of everything. All right. We'll loop through the traits, and for each trait, we're going to loop through each function in the trait. So we got a vote function, we got a may vote function. So let's loop through each of those. Now you could do object.keys, and you would get the name of each function. I'm going to do object.entries and get both the name and the actual function in that trait. So for each, and in here we've got the name and the function. All right. And if you don't know what object.entries does, is it's going to grab every property of an object. In this case, we have an object where vote is the name of the property and this function is the value of the property. And object.entries is going to turn it into an array where each element in the array is one of the, this will be the 0th element, this will be the index 1 element. And in each one of those elements, it'll be an array with two things in it. The first one will be the name, and the second one will be the value. And in this case, the value is the actual function, which is why we're going to do name and function and destructure it into an array like that. So now that we have that, we're going to add those on to the class prototype here, which is what we're going to do. We're going to do class.prototype name equals function. So now we add the functions onto the prototype, which when you do a class, it technically is just creating a prototypal object that you can instantiate from under the hood. So this right here will implement the thing. Now let's do one so that we can check whether something has a trait. That is a new person. And maybe we want to have a function where we like do the voting and we go over a series of objects and we don't know if the objects passed in are persons. They could be any sort of object. So we want to say like if has trait can vote, then object.vote, and then we want to be able to call do the voting on Bob, right? So we need to have has trait implemented so that we know that whatever gets passed in here is allowed to vote. If you were in a strongly typed language in here, you could say only something that implements that can be passed in. In this case, we also, instead of just doing the if thing, we could also assert that has trait Bob and can vote. And otherwise, only votables or only objects implementing the can vote trait may be passed to do the voting. Something like that, right? And then you can do object.vote. And this will help make sure that we don't accidentally do, something, pass in the wrong sort of thing. But this means that into this function, we don't have to just pass a person class. We can pass in any class or any object, really, as long as it can implement these functions. Now, we don't want to, every time we do this, crawl through Bob and check that he has all the same functions. So that's what has trait is going to do. It's going to go through and return trait. We're going to do object.keys on trait because we just need to check whether it has the same functions, vote, may vote, etc. Let's actually do object.entries on trait. I think we need to do that and reduce. We're going to do this reduce pattern. If you don't know reduce, then go and check it. But effectively, this is going to turn into a Boolean because we're giving it true, and it's going to give us either true or false. And each element cur, I'm going to destructure that into the name and function just like we did up here. I'm going to tighten that up a little bit. And so we're going to basically try to prove this wrong, right? If a single function in here is not in an object, that means the object doesn't implement it. So we start out true, and then we're trying to prove it wrong. We're going to return ACC, which starts out as true, and it could be false. So we're going to do and, because if it's ever false, we just want to return that. And I'm going to say type of function is function. Now, the cool thing about that is if like the property just doesn't exist, vote, if it just doesn't exist, then that'll be false because type of will be undefined. But also if vote exists, but it's not a function and it's something else, it's a property with, a static value or something, then that will fail. So this confirms that we have all the functions and that they are functions. So yeah, actually, in this case, we actually don't even need name, do we? No. Okay, I've done this wrong because we don't want to just check type of function is function. That's not going to do that. Type of object name. All right, so actually what we can do here instead of entries, we can do keys because we don't need the function value itself from a trait. We just need the name because we're checking that from the object. All right, so this should do the thing. So now, if we run this, let's see if I have any bugs in here. Bob is voting. All right, so do the voting, did have Bob vote. Let's make another object, Larry, and he's just a thing, and he can vote. And if you do this, I can fake vote because I don't implement the may vote function. So technically this does not ascribe to the can vote trait. So if I try to do the voting on Larry, right, I can fake vote. Okay, it does do it. Has trait Bob and can vote. The assert didn't fail. So I think that we've got an issue here. We returned this and this. So if that ever returns, all right, let's debug together because we have that. And Larry can vote, but all right, so let's say if Larry doesn't have anything, it still tries to do it and that still fails. All right, so if has trait fails, all right, we got true and true. Let's log the object that we're doing. The object has nothing. Let's do type of name like that. And it's always returning true. Okay, what actually is name then? Because name is the current element and object keys of the trait that we're passing in. Vote and may vote. So what is object vote if object doesn't have vote? So how is it a function when we say has trait? You pass in, oh, because we're saying has trait Bob and not object. Duh. So our function works. Thank you for debugging with me and being patient. So our function works. We were just testing the wrong thing. We're testing Bob directly instead of whatever it was we were passing in. All right, so if we do this, now it throws only objects implementing can vote can be passed to do the voting. All right, great. So Larry can't make it in. Even if he has vote, all right, I'm in a habit of using single quotes. I've worked in repos where the linting makes you use single quotes for strings, so don't at me. And that still throws, even though we have vote, because we need both. Now, technically, you don't have to be a class that you had with traits on there, as long as you implement the same thing. So this can kind of be used for interfaces in a way, where you're making sure something ascribes to a certain interface. As long as we have, you know, the correct functions, it should work. So it's not can vote, it's may vote. All right. Then you can do it. So this, I think, right here is not a whole lot of code in exchange for the ability to effectively use the language feature of traits. And I'm curious if you're seeing this and you're like, no, don't do that. Don't do all this complicated nonsense. You could just do such and such. If you have something that you use to do this sort of compositional style, then 100% leave a comment and let me know what it is, because so far it seems like a lot of people have opinions on what counts as too complicated. And this right here, even though to me it's 3 functions, the assert is just a little utility, but really it's 2 functions to implement traits as a language feature in JavaScript, and in a way interfaces too. I think that's pretty neat. And I might actually start using this in places, because if you know what a trait is and what that means, this is actually fairly readable. Even for people who in the JavaScript language will be like, what do you mean JavaScript? JavaScript doesn't have traits. Why do you have traits and stuff? As soon as you learn what a trait is, this makes sense, right? Unless I'm wrong. You can comment, tell me if I'm wrong. Anyway, just wanted to show you all that.